Hello, welcome. Let's try to solve another LeetCode problem. 2952. Minimum number of coins to be added. There's so many similar problems in LeetCode. At least there are going to be 3 similar problems, but I'm going to explain one by one. Yeah. So this means that if we can solve this problem, definitely we can solve other 2 problems. So like the LeetCode pattern arrays, it is exactly the same. Yeah. So let's try to understand it. So we are giving 0 index integer array coins and representing the values of the coins available and an integer target. So we are having such kind of coins 1, 4, and 10, and we have a target value which is 19. So an integer x is obtainable if there exists a subsequence of coins that sum up to x. Yeah. So what is the meaning? So this means if we have a value of 1, definitely the x gonna be and the x can be a 1. If we have 1 and 4, so this means that the x can be 1, 4, or can be 5. Yeah. So this is the meaning. So we're going to return the minimum number of coins of any value that need to be added to the array so that every integer in the range is obtainable. Yeah. Actually, we want to obtain all the values from 1 to target, and for this example, the target is going to be 19. Yeah. So a subsequence of an array is a new non-empty array that is formed by the original array by deleting some let me remove it, some of the element without disturbing the relative positions of the remaining elements. Yeah. So this is just the meaning of the subsequence. So what are we gonna do? First of all, this coins array is not sorted. For this example, it is sorted, but as you can see, the second example, it is not sorted. We have 1, 4, 10, 5, 7. It is not sorted. Yeah. But according to the greedy idea, if we were to have all the values, we have to sort the array first. So for example, if we have a value of 1 and 2, so what is going to be the range? The range can be 1 if we only choose 1 coin, or it can be 2 if we choose a coin of 2, or we choose a coin of 1 and 2. It can be 1, 2, 3. Yeah. But what happens if it is not sorted? It is 2, 1. First of all, we're going to choose a coin of 2, but currently we don't have a value of 1. Actually, we need a value of 1. Yeah, but we don't have it. So what are we going to do? We need to add a coin of 1. Actually, we don't need to add it if we are doing it from 1 to 2. So this means the array must be sorted. So this is going to be the first step. So the second step is that we're going to try some examples to explain how can we reach the target. So for example, we have a value of 1, 4, and 10. Yeah. And our target is 19. So first of all, we're going to have a value of 1. Definitely we have it. Yeah. And then the second step is that we're going to choose the next number, which is going to be 4. So if we choose the next number, what's going to be the range? Because from the beginning, the range is only 1. If we choose the next number 4, so the range is 1 is here, another one is 1 plus 4, it's going to be 4. And it can be 4 itself. So it means 1, 4, and 5. Yeah. So it means some number is missing, like 2 and 3 is missing. Yeah. And also for this example, we're going to use 4 to plus 0 and plus 1. So this means it's better for us to add a padding of 0 because this is easier for us to understand the problem. Yeah. So if we understand it like this, let's just use some easier examples. So if we have a 0, 1, and 2. Yeah. So currently, if we have the range, if we have the minimum number of coins, if we have the 1 to target obtainable, so currently we're going to set it to 0 to target obtainable. So 0 to 4, 0 to 2 is obtainable. So currently we are sure that 0 to 2 is obtainable. Yeah. Now we're going to have the next value. So for the next coin, so if there's a coin of 1, what's going to happen? So this means the range is going to be 0 to 2, and then 0 plus 1, 2 plus 1, it's going to be 1, 2, 3. So 0 to 2, 1 to 3, there's overlap. So this means the final result is going to be 0 to 3. Yeah. So what if the next value is 2? So what's going to happen is, so this is 0 to 2, so here going to be 2 to 4. So 0 to 2, 2 to 4, it means there's overlapping. with a value of 2. So definitely we're going to have a range from 0 to 4. Yeah. Next, if we choose a value of 3, what's going to happen? 0 to 2, 3 to 5. Yeah. So this means the range is going to be starting from 0 to 5. Yeah. Because if we have a 3, 3 plus 0 going to be 3, 3 plus 2 going to be 5. So this means the range is going to be 3 to 5 plus 0 to 2. So it's going to be, yeah, 1 to 5. Yeah. So currently everything is okay because definitely there's overlapping. So here we think 0 to 2, 3 to 5, it is also overlapping. It means it can be connected because 0 to 2, then 3 to 5, it can be connected. What happens is for the value if it is 4. So currently we have a range of 0 to 2. If we have a value of 4, what's going to happen is that the value going to become 0 plus 4, it's going to be 4, 4 plus 2, it's going to be 4 to 6. Yeah, right. It's going to be 4 to 6. So this is a 0 to 2, this is a 4 to 6. So this means some number is missing. What number is missing? Which going to be 3 is missing. So this is 3, we're going to count this number 3. Yeah, because currently this 3 is missing. Yeah, so this is the idea. So we're going to set a variable s to represent the range from 0 to s minus 1 inclusive is valid. So from the beginning, the s is going to set to 1. So this means from the beginning, we're going to have a valid range which is 0 to 0. Now we're going to add the first number, which is 1. So if we add the first number 1, it means 0, 0 with a 1, 0 plus a 1, 0 plus a 1, it means, yeah, the range going to become 0 to 1. And the value of s going to become 2. Yeah, because currently s is 1, it means this value going to plus s gonna become 2. Yeah, so this is our first value, which is 1. Now we're gonna use the second value, which is 4. If we are going to use the second value 4, because this number 4 is more than s. Yeah, 4 is more than 2, right? Because this 4 is, if 4 is less than or equal than s, definitely it is okay. But currently this value 4 is more than s is 2. So this means we need to add a value, which is s. So this means s gonna equal to 4. S gonna plus s. Yeah. Yeah, because currently this means the number 2 definitely is gonna be missing. So s gonna plus equal to s. So s gonna equal to s is 2. So s gonna equal to 4 currently. Yeah. So the idea is that if 2 is missing, we're going to add this 2, and our range is from 0 to 3 because we are adding a 2. So currently this value s is 4, and the range is valid from 0 to 3, and we add with one number. Yeah. Next we're going to have a value of 4. Yeah, and our s is 4. So this means the next value is yeah, next value is still smaller and equal than s. So this means it's going to be expanded from 0 to 3 plus 4. So the valid value going to be 0 to 7. 3 plus 4 is going to be 7. Yeah, because 0 plus 4 is going to be 4 to 7. 0 3 to 4 to 7 is going to be 0 to 7. Yeah. Next we're going to have a value of 10, and our s is 8. Definitely 10 is more than 8. If this value 10 is more than 8, so this means we need to add a number which is going to be 8. From the beginning s is 8, so now we're going to plus 8, so this means s is going to become 16. Yeah, so if s becomes 16, this means our valid range is 0 to 15. Yeah, so this is valid. 0 to 15. Yeah. Now we have the next number, which is 10. So this means the range is going to become 0 to 25. Yeah. Because 10 plus 15 is going to be 25. 0 plus 10 is going to be 10. And there is overlap from 0 to 15. 10 to 25, so it's going to be 0 to 25. If it is 0 to 25, this 25 is more than the target, so we're going to go out of the while loop, we're going to stop checking, and our pattern result is 2. We only need to get 2 coins, and then we're going to have a range of 1 to 19, because 0 to 19, basically it is 1 to 19. And the idea is just the greedy idea. We're going to always choose the smallest number. We want to sort the coins array first, and then we're going to always choose the smallest number. And we're going to set S as the initial range. It's going to be from 0 to S minus 1. Yeah. Now let's just start coding. As the coins is not sorted, so we need to sort it. So this is the greedy idea, because only in this way we're going to have the minimum number of coins, and then we're going to have the range from 1 to target obtainable. So this is 1 to target obtainable. Now we're going to set I equal to 0 and S equal to 1, and I'm going to set a result to 0. Yeah. So from here, I'm going to use a while loop to check. So while this S is less than or equal to target, so it means everything should be valid. Yeah. So I'm gonna check the I. If I is less than length of the coins, and yeah, and current value is gonna be coins I. Yeah. If it is less than or equal to S, basically it means there's an overlap, or it can be connected. Yeah. So S gonna plus equal to coins I, and I gonna plus equal to 1. So this means we're gonna choose the next coin. Otherwise, we don't need to choose the next coin, but we need to patch a coin. We need to find another coin, which is gonna be S, and we're gonna update the result because we used another coin. Yeah. Finally, we're gonna return the result. Yeah. So this is the coding, and let me just submit it to check if it works. Yeah, as you can see, it works, and it's pretty fast. I think the difficult part is this is a greedy problem. We need to sort the coins first, and then we need to set some variables. Why we're gonna set the S equal to 1? Because this is a this is the hard part. Actually, the hard part of the problem, because we want to use the range from 0 to S minus 1 as valid, and this is easy for coding, and it is also easy for analyzing the problem. Normally, we cannot think about this S equal to 1 or with this kind of idea, because definitely this is a difficult idea to think about. I think we have to practice a lot, because there are a lot of similar problems. If we solved one problem before, maybe we can think about this kind of a greedy idea to solve the problem.